In a healthy Active Directory forest, domain controllers form a tight network, continuously transmitting replication data along established pathways to keep the entire system synchronized. When a source domain controller is demoted and deleted from the environment, you would expect the network to instantly adapt and sever the connection. That does not happen. Instead, the surviving destination domain controllers continue sending inbound replication attempts directly into the empty space where that deleted server used to be. This behavior isn't a glitch. In an unpatched default Windows Server 2003 environment, this persistent polling is the intended design. Demoting a domain controller does not instantly sever its ties to the replication topology. It creates a hidden operational window where the ghost of the deleted server remains active on the network, requiring manual management by administrators. The component responsible for handling the deletion of a domain controller's NTDS settings object is the Knowledge Consistency Checker, or KCC. The KCC is the internal architectural process that automatically generates and maintains the replication topology connection objects. The KCC relies on a specific directory attribute, replTopologyStayOfExecution, to mathematically determine exactly how long these ghost connections are allowed to persist. This extended window of persistent polling creates a serious network vulnerability. We are going to map the exact logic gate the KCC uses to maintain these connections. We will calculate the hard mathematical limits of this persistence and detail the network spoofing exploit that forced Microsoft to rewrite the architecture in Service Pack 1. Understanding this legacy behavior shows how early versions of Active Directory prioritize topology stability and disaster recovery over immediate localized network isolation. To see why polling continues, we zoom inside the destination domain controller's directory partition. Here, the reps from attribute holds persistent configuration metadata pointing to each source domain controller. Destination servers rely exclusively on this metadata to authorize outgoing polling requests for directory changes. The KCC uses this specific metadata directive to manage the creation and maintenance of the physical connection objects between the servers. There is a strict division here between the logical metadata directive stored in reps from and the actual physical connection object it represents. When running diagnostic tools like repadmin.exe to check replication status, the tool reads directly from this persistent metadata, not from live physical wire traffic. The reps from attribute acts as the overriding source of truth for inbound replication, dictating behavior regardless of the source server's physical status. The process starts the moment a source domain controller is demoted, which triggers the deletion of its NTDS settings object. The physical connection object managed by the KCC is instantly dropped, but the logical directive remains. The reps from attribute is left entirely intact on the destination server. Because the metadata is still there, the destination server keeps polling the deleted source. This generates the sudden flood of failed replication attempts visible in directory service event logs. The demotion event forces the system into a split brain state. The logical directive to replicate outlives the physical existence of the target server. The KCC logic gate detects this discrepancy, an orphaned reps from value lacking a physical connection. It then queries the deleted object's tombstone, extracts the exact chronological deletion timestamp, and weighs the elapsed time against the configured replTopologyStayOfExecution interval. The KCC does not blindly trust physical network disconnections. It strictly executes this mathematical verification loop before authorizing the removal of any replication directive. This replTopologyStayOfExecution attribute is stored within the directory service object in the configuration partition. In an unmodified Windows Server 2003 environment, its default value is exactly 14 days. The stay-of-execution interval is permanently capped at a maximum of half the total tombstone lifetime. If configured to 30 days, the math creates an unbreakable wall at exactly 15 days. A 20-day manual entry forcefully snaps backward to this 15-day limit. Only when this mathematically bounded interval is fully met or exceeded will the KCC permanently purge the reps from value and cease polling. Active Directory enforces strict chronological limits on topology retention, ensuring ghost connections cannot exist indefinitely, even if an administrator severely misconfigures the persistence values. During that 14 to 15 days stay of execution window, The destination domain controllers are blindly pulsing polling requests into empty network space. This topology map shows how an attacker can exploit the open window. They deploy a rogue node that assumes the IP address and routing identity of the demoted server. The rogue node intercepts and successfully answers those lingering reps from polling requests. The attacker then leverages this connection to inject poisoned replication changes and corrupted topology data directly into the destination server. The destination server accepts the payload because the persistent reps from metadata effectively pre-authorizes the connection, validating the rogue node as a legitimate source. The exact KCC safeguard designed to preserve replication topology inadvertently creates a highly trusted, authenticated backdoor for network spoofing attacks. To neutralize this spoofing threat, Microsoft released Windows Server 2003 Service Pack 1, which rewrote this specific persistence behavior. In Service Pack 1, the stay execution mechanism is completely disabled by default. The moment a source domain controller is demoted, the reps from data instantly dissolves. Destination servers never enter a split brain state and instantly cease polling the empty network space. Without the destination server initiating outgoing polling, malicious computers have no incoming requests to answer, rendering the spoofing vector useless. Engineers can manually explicitly provide a value for replTopologyStayOfExecution in SP1 to re-enable the mechanism if highly specific legacy topology requirements demand it. Service Pack 1 decisively closes the spoofing vector by default. But by leaving the manual override available, Active Directory maintains its core architectural flexibility, forcing enterprise engineers to actively choose between extreme topology resilience and immediate network security.